My name is Michael Chadwick, and this is my course project for the Managing AI Projects course for Coursera. I was going to take a quick moment here to go over the project itself. As you can see here, the step-by-step instructions. Choose a problem within your industry or field of interest that you think might be an opportunity for machine learning. As part of that, we're going to provide an opportunity evaluation, CRISP DM, business understanding, solution validation plan, ML system design, and potential risks. And while doing so, we're going to cover all the areas: opportunity evaluation, understanding a CRISP DM, validation plan, ML system design, and potential risks in production. So, starting things off here. The opportunity evaluation. So the problem introduction is in e-commerce, retaining customers is very critical for sustained growth. So understanding churn, which is the rate at which customers leave your product, and its many causes of churn is vital. And certainly predicting which customers are likely to churn allows a company for targeted interventions to retain them through any host of different solutions, right? So why is this an attractive opportunity? So answering the three questions as laid out in Module 1, is there a problem? Yes. Increasing churn rate or its corollary, a decline in the rate of returning customers, is a serious red flag that can doom many companies. So this is a very common problem for a lot of companies. So to answer the second question, does someone care? Absolutely, it's a common problem. Further, many internal departments within those companies, like marketing, media buying, and customer success, just to name a few, work directly and indirectly with improving churn for companies. So it's a very vital problem. And can ML help solve it? Absolutely. Machine learning models can accurately predict customer behavior based on past interactions, purchase history, engagement metrics, a whole host of other features. These predictions can inform targeted marketing campaigns, personalized offers, and other strategies and tactics to improve churn rate. Now, as this lines up with CRISP DM, once again, going through everything: business understanding, define the problem. Customer churn is a significant challenge in the e-commerce industry, where retaining customers is crucial for long-term profitability. Problem we aim to solve is identifying which customers are at a high risk of churning so that the targeted retention strategies can be deployed to retain them. So one of the critical pieces of this is we would set a marker, like how long after a user's last visit or last purchase do they then fall into the churn bucket, so to speak. So in terms of defining success, we're kind of looking at it in two ways. Well, in terms of business outcome, obviously, as mentioned, we're looking to reduce churn. And so reducing churn will generally have a lot of downstream effects. So for example, improve customer lifetime value, or CLTV. So the amount of money you would make from a customer over the lifetime of their visit. Because inevitably, a customer will eventually leave a product, right? And so one of the challenges for an e-commerce company or any company like that is to try to keep them as long as possible. But lifetime means at some point they will depart. So we're looking to sort of just extend that life a little bit longer. And of course, marketing efficiency. If the marketing department knows who is at most risk for leaving, they can use their limited time and resources to be able to accurately and action to find these people and bring them back into the fold. And in terms of the model outcome, just general metrics that we're looking to ensure a strong model, with that being accuracy, precision, and recall. Now, in terms of some of the factors that could impact being able to determine the prediction for this, just some ones off the cuff: purchase frequency, how often they buy; average order value; what the user actually does when they're on the platform; general demographics, like where you're at, how old you are, what time you visit, things of that nature; email engagement. Obviously, I mentioned marketing. So if marketing is going to send out email campaigns, for example, micro-targeted to these people who are in the potential churn, we want to know what the success rate already exists for our marketing campaign, so that can be fed in as well. And of course, payment method. Do people that pay by debit react differently or more likely to churn if they pay by a credit card? Okay. And further to that, there are certain types of credit cards that lead people to stay longer. These are all the things that the model would help work out or find relationships with. Now, in terms of the validation plan, gathering data, the main data sources we would probably want to look at, just to name a few, once again, this would all be worked out during the proper planning process: their purchase history, their order values, both total order value as well as their average; timestamps, as mentioned before, when they visit; Traffic analytics, meaning what types of traffic sources are they coming in from Google? Are they coming in from social media? Are they coming in from email? How people come in will probably have an impact on their ability. So we want to definitely pull from that source, as well as email, as mentioned before. Profile data, generally any kind of e-commerce, whether it's your Amazons, your Walmart.coms, Newegg, what have you. You're logging in, you're providing some information about yourself. We want to capture that. And of course, the critical one would be credit scores. Whatever access we can potentially get that information as well. Might also be an indicator about one's ability to churn. In terms of collection, we would collect this through APIs, of course, simple database queries, external sources, any kind of third-party service that we use that in the process collects user information. We probably want to leverage that as well. And just good old-fashioned exporting files, CSVs, and the like. In terms of storage, it'd be most likely cloud storage, and we would most likely organize it by customer ID. In the instance that I work in the e-commerce industry, in all likelihood, we would not be focusing on guests, people who can purchase things without having to be a member or registering. We'd focus, at least in this initial wave, on those who have registered, because that allows us to more accurately determine churn. In terms of validating the data, we do a number of data quality checks, as well as data cleansing and a host of validation techniques. In terms of how we begin exploring the data, we would start very simple and then get more complex as we move through. So as you can see, that we'd initially begin with univariate analysis. We'd look at just one feature or one factor and see if we can identify any sort of correlation off the top. So this will help with feature selection. Once we've kind of had that look, we will then begin to combine a couple of these different things with bivariate analysis, scatter plots, box plots, correlation analysis. And then last but certainly not least is the multivariate. So that's when we're getting in the clusters, we're starting to identify certain groups or as determined by the algorithm and the data that we currently see as to if there's any correlation here from the top that'll help feed into the next stage of the process, which of course is data preparation. So in terms of the split, I'd probably do a 70-20-10. 70% of the data is going to train the model itself. We'd use 20% of the leftover data to validate, and then of course we'd run the test on the 10%. Now, in terms of the feature set, once again, similar to the from the slide earlier, this is sort of broad. Obviously, a lot of the stuff would be narrowed down as we kind of iteratively go through each of these steps. But payment method, timestamps, total purchase, total order value, visit frequency, how many times over a 30-day period did they visit, recency, how since, that'll be very critical. It's a very critical metric to know in terms of churn, country of origin, requests, and chargebacks, right? So there was also negative outcomes or negative actions we'd absolutely want to look at, because obviously if someone has a negative interaction with, say, our customer service department, or they didn't get the thing that they ordered and they found customer service is poor, then the likelihood of churn is going to be quite high. So we'd also be spending a lot of time in looking at not just engagement, but negative interactions or things perceived to potentially be negative, and then feeding that into the model as well to allow us to better identify who are potential churn. And in terms of missing data, we'd run through to identify missing values and how to deal with those missing values. As you guys know, there's a number of different steps that could be done. Normalizing the data over, say, on a 30 to 31 day, 28 day, making sure that that's all normalized. And of course, encoding categorical variables, which is a very important thing, because we need to be able to take those categories and put it into, encode it in a way that can be read and understood by the model. In terms of the modeling itself, we're thinking most likely it's a binary classification. Will they or won't they churn within X period of time? There are some possible model types here, decision trees, neural networks, but ultimately, as you're going to see in the future slide, I'm thinking logistic regression is probably the most. Just keep it very, very simple. And in terms of valuation, probably do cross-validation. And of course, tuning hyperparameters as we kind of iteratively go through this process during validation. In terms of the validation plan, in terms of the concept, we would develop a predictive model that analyzes customer behavior, including purchase frequency, average order value, and browsing patterns, to identify those most likely to churn. From that, we would probably segment that group further into basic areas: possible churn, likely churn, definitely churn. That may or may not be determined by the model. We may take the data that's being produced by the churn or not churn and then break that down further. And of course, for each segment, we develop unique strategies to execute on those people. Now, first, in terms of the validation, we would train the model on a subset of historical data, then validate it against the holdout set of validation and finally testing data. A/B testing would be employed actually to measure the effectiveness of the targeted retention campaigns based on the model's predictions. So we would start off something small, of course. We're not going to just dive right into it full-heartedly. We'd probably identify a segment of that possible churn, and we would either run a marketing campaign of some sort, or a push notification, or customized promo codes, stuff like that, and see what the impact is, and take it from there. Now, in terms of the design, for data collection, we would use customer transaction records, web analytics, and interaction logs from the platform itself. Google Analytics is what we use in my company, so we would almost certainly use the data collected from there as well. In terms of model selection, as I mentioned earlier, we would use logistic regression, mainly for its simplicity. It's very easily interpretable, so explaining it to the marketing department or the customer support team is very easy to sort of explain it, as I'm doing right now in this presentation. It'd be very simple to sort of explain how it is that the model is working and how it's coming up with its results. Now, in terms of some of the design decisions as laid out in Module 4, cloud versus edge, definitely cloud. We don't need the model to run outside of the cloud. We don't need any on-device sort of AI. We're not reading fingerprints or facial recognition or voice recognition to determine any of this, so keep it cloud. In terms of offline and online, offline as well, it's easier to implement. We do not require any real-time predictions for this, right? Because ultimately it's going to be marketing campaigns. We do not need to have real-time or even same-day results to be able to build up the proper campaigns that we would want. And at a certain point, we'd actually automate a lot of these campaigns. So we can kind of take a rather slow, progressive approach, which lines into the last one, batch versus online batch. With a weekly frequency, we don't require immediate predictions, plus a batch is easier to integrate and monitor, right? So in this hypothetical situation, this will be the first time that the company would be using machine learning in order to enhance its existing product suite or enhance the profitability of the product suite. So starting out simple with every step of the way allows me to be able to teach everyone else in the company how it is that they're using it, where they see the value, and then so very slowly, once they start to get an understanding and see the value that machine learning can provide, then they become a little more eager and open to taking on things that are maybe a little bit more sophisticated, such as the e-commerce I work for is a two-way market. So perhaps as one example, providing a tool for sellers to be able to identify what is the appropriate price range they should put their product on sale for. And that's just like one idea among many others that we could do. But starting off with something very simple like this has a very immediate marketing, i.e. revenue generating potential. That'd be a very easy sell for those within my company. Now, in terms of potential risks in production, the main ones, of course, is training serving skew. The difference between training data and real world data would lead to performance issues, as I learned in the class as well as you guys did. Training serving skew would pretty much reveal itself relatively quickly. So, but it is a risk we need to be mindful of. And of course, related, which is more of a long-term issue, data drift, right? Could the data change over time, making the model less effective? There could be any host of factors that involve, that have a negative or even positive impact on one's ability to churn outside of what the machine learning model tells us. And so we could be inappropriately putting people in those buckets. And generally, if they're going to fall within the churn bucket, in all likelihood, we're going to probably run some sort of marketing campaign or variation that's going to cost us money, not just internally, the staff to execute it, but generally like eat some of the profit we need in order to get them back hooked in and buy it. So we definitely want to make sure that the bucket that these people are being put in is accurate. And this is absolutely what we want. In terms of mitigation, we'd want to implement a host of different monitoring tools to track the model's performance, in particular at the very beginning, and of course retrain the model periodically to mitigate data drift. I think that's something that we've probably done on once we've established the value of the model and it's kind of running. Probably would be something we'd want to audit every 6 months, every 90 days of 6 months. Fortunately, because we'd be feeding new data in every weekly, you'd be able to relatively easily monitor, see if everything's kind of going along nicely from the data collection through the pipeline, through the model, and then the results it produces. So I hope I've addressed all the concerns, and thank you very much for your time.